Okay, I'm going to talk you through the topic assessment. Here's a very important piece of work we're going to be doing. The first one is expanding this up using your 1 plus x to the n formula. So make sure it starts off with a 1. So divide everything by 3, bring the 3 out along with the power, and just use your formula. Tidy it up, multiply through, and the valid comes from here, where it starts off 1. So valid for x over 3, remember the minus signs don't count, bring it out, becomes a multiply. Number 2 is a simplify. So in number 2, difference of two squares in the top, factorise the bottom, and they knock off. So that wasn't too bad. Number 3, with your fractions, always factorise first. So I'm factorising this first. You're subtracting them, so make the bottoms the same. This one needs an extra x minus 3, so put it on top, times out the top, subtract the tops, tidy it up, factorise it. They cancel off, so it doesn't need factorise, and that's you finished. Number 4, partial fractions. Okay, so first of all, factorise. That's the difference of two squares. That's 3 squared minus 1 squared. So split them up into their factors, then into your separate fractions. Partial fractions as normal. Find your a and b, and make sure you put your a and b back into that initial expression to finish it off. Question 5 is another partial fractions. So just your normal partial fractions there. Question 6 is a division. So what you're going to do in question 6, factorise everything first, turn your fraction after the division sign upside down and cancel off anything. Question 7 is a division. So take your top line, divide it by the bottom, and just work through your wee division there. And remember to give your answer as the answer, is the top line, plus the remainder, minus 42, over the divisor. Number 8 is you are told that this is approximately equal. So we're going to use our binomial expansion here, because you can see the way the question there is written out in terms of like the binomial expansion, the 1 plus nx plus n, it's 1 over 2x squared. So the first bracket has no power, so just let it sit there. That won't do any harm just sitting there. The bottom one comes up as a minus 1. You can now work out your 1 plus nx formula in here for this bracket, tidying it up. Now, the question goes up as far as x squared. I'm now going to multiply through by 1. Then I'm going to multiply through by x. But when I'm giving my answer, I don't need to include this x cubed, because it only goes up as far as x squared. So you should be left with this expression. And if you compare that to what they have, you've got 1. Your a is 3 and your b is 6. Number 9 is a repeat. So it's a over the first plus b over the second plus c over the repeat, and just your normal way. Second bit of it is onto the binomial. So you've got your fraction written out. So it's 1 minus x to the minus 1 plus 2, bring that up as a minus 1, plus, oh, I've just noticed there I've made a mistake. Now it's got a 6 in there, 1 add 2x to the minus 2. So it's the first bracket, add the second bracket, add, I've got my 6 back in again here, 6 times the second bracket. I'm using the 1 plus nx formula in each of those brackets. So multiply out your brackets and tidy it up. And then you're valid from expression. The first one is valid for x less than 1. The next one is valid for 2x less than 1, which is the same as x less than a half, and you bring your 2 out. And that's just the 2x less than 1. Combining those together, you have x less than a half. And over for question 10. Okay, first bit, partial fractions, just your normal way. Part 2, hence show that f dash x, oh, I've got to differentiate that. Good wee question here. So here's your fx. If you write that as a bracket, just bring that up to the top line, you can differentiate it. Remember how to differentiate a bracket. Power goes to front, take 1 off, and multiply it by the derivative of the bracket. So power goes to front, take 1 off, multiply it by the derivative of the bracket, and that's me tidying it up. Part 3, turning point is when dy by dx equals 0. So take this and put it equal to 0. So you can see me making the bottoms the same and working out the tops, etc., to give me x equals minus 1. It only wants the x coordinates, so I don't have to find the y. And the last bit of that question is wanting the second derivative. So I have the first derivative here. Differentiate it again, it's a bracket. So power goes to front, take 1 off, derivative of the bracket is 1. Power goes to front, take 1 off, derivative of the bracket is 1. So tidying that up and putting in your x value, you will see that it is beneath 0, so it's a maximum turning point.